In this video, we're going to talk about organizing data. So once you've chosen a good sampling method with which to collect your data, the next step is to organize your data into pictures. We're going to talk about using histograms, a stem and leaf plot, or a box and whiskers plot to help us visualize features of the data, such as the spread and center of your data. So we're going to start here with histograms. On the left side of your screen, you can see that I've collected some data about the 50 states. The data that we have here is the percent of adults aged 25 or older who have a bachelor's degree or higher in 2007. Now what I've done is I've taken that data and I've organized it in a picture called a histogram here on the right side of your screen. Across the bottom of your histogram is the range of values that a variable can take. It's been divided into equal sized intervals. In this case, you can see that my intervals go from 17 to 20 and then from 20 to 23 and so on. So they each have size 3. On the y-axis, we have the number of states that fall into each of these categories. Okay, so a given bar in my histogram tells me how many states lie in each category. So for example, this first bar tells me that there were 3 states who had between 17 and 20% of their population with a bachelor's degree or higher. As you look across the histogram, you can see very quickly that there were 16 states here that had between 23 and 26% of the adults with a bachelor's degree or higher, and so on. Now, technically, we can't have both bars containing an individual endpoint. And so we have to specify whether this endpoint here, I'm looking at the 20, whether this endpoint belongs in the bar to its left or in the bar to its right. In this case, we've designated that the right endpoint is not included in the bar. So for example, here we say this first bar contains states that had a percentage of 17 to 19.9%. Okay, so the 20 is going to go in the second bar if there was a state with a 20%. All right, so a histogram is just a picture of your data. The x-axis is your range of values broken into equal sized intervals, and your y-axis is the number of individuals, in this case states, that fall into each of those intervals. Okay, so let's make some remarks about building histograms. You need to specify whether your bins or your intervals contain the left or right endpoints. That's what I was talking about with that 20. Generally, we'll include the left endpoint and not the right endpoint. There's no right choice of bins or classes in a histogram. Too few are going to give a skyscraper graph. Too many are going to give you a pancake-shaped graph. Your goal is to give some valuable information about your data. So you want to pick the size for your intervals that's going to give you the most valuable information. So keep in mind, the purpose of graphs is to help us understand our data. Things we want to look for: the overall pattern, so the shape, the center, and the spread, and deviations from that pattern. For example, if there was a state in that last picture that had perhaps 5% of their adults with a bachelor's degree or higher, that would be a pretty large deviation from the rest of the states. Okay, so you're looking for things like that. That would be called an outlier, so individual values that fall outside of the overall pattern. Okay, so those are histograms. We also can display data using stem and leaf plots. So here's a smaller set of data, and to make a stem and leaf plot, we're going to separate each observation into a stem, which consists of all but the final digit, and a leaf, which is that remaining last digit. So for example, here, let's do the 12. The 12 is going to have a leaf of 2 and a stem of 1. Your stems can have as many digits as needed, but your leaves are always a single digit. So what we're going to do is write our stems in a vertical column with the smallest value at the top, and we're going to draw a straight line at the right of the column. Each leaf is going to go in the row to the right of its stem in increasing order out from the stem. Okay, so for this data, my stems are going to be 0, 1, 2, 3, 4, 5, 6, because this data ranges from single digits all the way up to the 60s. You can't skip stems even if you don't have any leaves that would go on them. So I couldn't skip from 1 to 3, for example. I need to have that 2 in the middle. And then my leaves are the rightmost digits. So for example, this 8 corresponds to this leaf here. Okay. And then we had a second 8 and then a 9. I need to list each observation once in my stem and leaf plot. So even if the value is repeated, I'm going to list it both times. Okay. On the one stem, I had an 11. That 12, remember, the 1 is the stem and the 2 is the leaf. Another 12 and a 4. On the 2 stem, I had a 24, a 25, and a 28, which gave me the leaves 4, 5, and 8, and so on. Notice here I did not have any leaves for the 5 stem, right? We didn't have any values in the 50s, but I still needed to include that 5 stem to show that we didn't have any leaves there. All right, so let's try building our own stem and leaf plot. So here are our scores for 25 students that take a math exam. And we want to start, I said stem and leaf. Let's start with a histogram to display the distribution of scores. So when you're building histograms, it's good to start with a frequency table that shows you the number of scores that fall into each range. So here I'm going to let my bins or my ranges of scores go by tens, okay? So my endpoints in my histogram are going to be 60, 70, 80, 90 to 100. And in each of those bins, I'm going to include the left endpoint and not the right endpoint. Since these are all whole numbers, that means my first bin is going to go from 60 to 69. So I look up at my data and I say how many values fall in this range. Well, I've got a 62, a 67, and a 68. So there are 3 exam scores that were between 60 and 69. We're going to do the same thing for the next bin. Okay, so from 70 to 79, let's count. I'm going to use the highlighter this time. I've got 75 here, 79, 72, 77, 75, 72, 73, and 76. How many values is that? 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to place an 8 here for the number of scores from 70 to 79. Go ahead and pause the video. You fill out the next two boxes and then come back and we'll compare. Okay, so hopefully you filled those out. You should have found 9 values from 80 to 89 and 5 from 90 to 100. Now when you make your frequency table like this, you should always double check that these numbers add up to the total number of numbers that you had. So here we had 25 students, so you should make a quick check that these add up to 25. And they do, right? I have 11 plus 9 is 20 plus 5 is 25. Okay, now what am I going to do with this to translate it into a histogram? Well, my histogram needs to have an X and a Y axis. On the X axis, I'm going to label it. It's the exam scores. And I'm going to mark, starting at 60, I'm going to mark equal sized intervals. So 60, 70, 80, 90, 100. My y-axis is the number of students that fall into each of those categories. So number of students. And those need to go all the way up to at least 9. So I'm going to go by ones up to 10. Okay, and now I'm ready to draw my bars. When we draw our bars, we draw them touching. So from 60 to 70, there were 3 students who had scores between 60 and 70. So I'm going to draw a bar of height 3. Scores between 70 and 80, there were 8 students, so I'm going to draw a bar of height 8 here. And then there were 9 students in the next interval. Oops. And then students in the 90s, there were 5. So there we go. Now sometimes you might want to write the numbers above just to be clear, although that's not required. You can always read by just tracing across to the y-axis, right? Okay, so there's our histogram for exam scores. Now notice these bars are always touching. Okay, unlike in a bar chart, these bars really do need to touch. They go right next to each other. All right. What if I wanted to use a stem and leaf plot instead to display this distribution of scores? So this is the same set of scores. So my stem and leaf plot requires me to draw stems and leaves. My scores range from the 60s to the 90s. We saw that on the last slide. So my stems are going to go 6, 7, 8, 9. And now my leaves are going to be the last digit of each of these scores. So let's start with the 60s. I've got 62, 67, and 68. Now I want to put my leaves in increasing order. Unfortunately here they already are in increasing order. So I've got to type in or write in the 2, the 7, and the 8 on the 6th stem. So I'm going to write 2, 7, 8. Now, what about scores in the 70s? There were more of those. We highlighted them in yellow last time. Let's do that again. All right, now I want to write these in increasing order. So I'm going to start with the 72s. Those were my minimums. And so I'm going to have 2, 2, and then I have a 73. So I'm going to write in a 3. And then I have 75 and 75. So I'm going to have leaves of 5, 5, then a 6, 7, and finally a 9 for the 79. All right, why don't you pause the video and fill in the leaves for the 8 stem and the 9 stem, and then you can come back and compare your answer to mine. All right, so in my 8 stem, I've got 1, 1, 1, 3, 5, 6, 7, 8, 9. And then on my 9 stem, I have 0, 1, 3, 5, and 7. Now, when you're building your stem and leaf plots, notice that I don't need commas between my leaves. Every single digit represents one observation in my data. Okay? So I don't need commas because it's clear that every single digit represents a single observation. Notice also I want to line up my columns nice and neatly so that I can see the general shape of my data from here. So for example, I can see, if you were to imagine taking and looking at this on its side, this has the shape of the histogram that we just built on the last slide. Right? It looks like the histogram turned 90 degrees to the right. So what do you think are the advantages and disadvantages of stem and leaf plots versus histograms? Well, the stem and leaf plot gives us a little more information, right? I can see clearly from the stem and leaf plot what each observation in my data set was, right? So I could list out all 25 scores. However, if I had a large data set, that would be really cumbersome to have to list out those individual scores. In that case, the histogram would be much more convenient. So for example, the histogram that we saw at the beginning of the video with the 50 states. That's much more convenient than having to make a stem and leaf plot with all 50 observations. With our stem and leaf plots, if we've got a lot of data, sometimes we want to do something called splitting the stems. So when you split the stems, you're going to have 2 of every stem divided so that the leaves with the digits 0 through 4 are going to be on the first stem, and then digits 5 through 9 appear on the second stem. So let's use the same data set again to split the stems. Let me add a slide here. Okay, so I'm going, whoops, let's use the pen. I'm going to have 2 of each stem. So I'm going to have 6, 6, 7, 7, 8, 8, and 9, 9. And now on my first stem, I'm going to put the digits 0 through 4. So I only had one of those. It was a 2. On my next stem, on the 6, I had a 7 and an 8. For the first 7, I had 2, 2, 3. And then I had a 75, so 5, 5, 6, 7, 9. On the first 8, I have 1, 1, 3, 5. Oops, not the 5, sorry. 1, 1, 3, and then the 5 goes on the next stem along with the 6, 7, 8, 9. And finally on the first 9 stem I have 0, 1, 3, and then a 5, 7. And so this just shows the data spread out a little bit more. That's called splitting the stems. We can use stem and leaf plots to display two data sets at once in one stem and leaf plot. So here I'm going to put my stems in the middle, and then the leaves for each class on either side. Now when you write your leaves on either side, you want to go from the inside, so close to the stem, out. Okay, so you're going to be increasing from close to the stem out, either to the right or to the left, depending on which side of the stem you're on. Okay, so here, for example, you see this 72 from Class A is listed with stem 7 and this 2 here on the left. Okay, so it asks you to describe the center and spread of each distribution. Well, what do you think center is? So perhaps we should look at the middle, right? Center is the middle. And so how could I find the middle? Well, a stem and leaf plot helps us to do that because our data is already organized from smallest to largest. So I'm going to count the number of observations. In this first class, there was 1, 2, 3, 4, 5, 6, 7, 8, 9. So the middle is going to be between it's going to be the 5th number in my list in increasing order. So 1, 2, 3, 4, 5. This digit here is going to tell me what my middle was. My center here is 77. Right? There are 4 numbers that came before it, and there are 4 numbers that come after it. What about the spread? Well, again, I can look at my stem and leaf plot, and I see here that my minimum was 56, and my maximum was 98. So my spread went from 56 to 98. All right, you try it for Class B, and you can check with me in class. Okay, so how else could we measure center? Well, the first measure of center we want to talk about is the mean. The mean is what you might think of as the average. So it's the value that you get when you add all of your observations and divide by the total number of observations. So in this case, we're calling that n. This notation here on the right, this is called sigma notation, and this just means add up all the xi's from I goes equal to 1 all the way up to n. Okay, so this notation here is exactly what's on top on the right. Okay, so this is something you're probably already familiar with. So if I wanted to know the mean exam score for Class A, I would add up all of the exam scores and then divide by 9. And I get a mean of 78.89. All right, you find the mean exam score for Class B. So you should have added up all the numbers in the right-hand column. There are 10 of them, so we're going to add these up and divide by 10, and what do you get? I got 81.4. Now if we look at the stem and leaf plot that we made over here, that seems reasonable that it should have a higher mean because it had more scores that were in the 80s and 90s than Class A. Okay, the other measure of center is the median. That's what we were doing back with that stem and leaf plot. The median is the midpoint or the middle entry of a distribution once you've put it in order. If n is odd, the median is exactly the middle observation when you put your observations in order from smallest to largest. So we could list Class A's scores from smallest to largest, and you can see here that 77 is the middle number. So the median, we use a capital M, is 77. When n is even, the median is the mean of the two middle observations when we order the observations from smallest to largest. So for Class B, we're going to put the scores in order from smallest to largest. There were 10, so we have two numbers here in the middle. And so what we're going to do is add those two together and then divide by 2. So the median for Class B was 83.5. All right, I'm going to stop here. We'll talk about spread together in class and other measurements or statistics that we can compute from our data. Make sure that you get started on the homework and let me know if you have any questions.